Hello friends, my name is Ashwini and welcome back to my YouTube channel. Today we are discussing our big data algorithm, which is called as Flajolet-Martin algorithm. In this algorithm we will be trying to find out which are the distinct elements. So how the question will be given to us, that a stream of integers will be given and a hash function will be given. We have to calculate how many are the distinct elements in the stream. So for that, the first step will be, we'll have to find the hash function for the given stream. So we will write down our stream in a tabular format like this, and we will try to calculate hash function of each and every stream. Now as in the question, it is given h of x, which is 3x plus 1. Here the x we will replace with 1 stream. That is why for the stream 3, it is 3 into 3 plus 1 mod 5. So that is 10 mod 5, 0. So for 1 it is 3 into 1, 3 plus 1, 4. That is 4 mod 5, which is 4. Like that you will complete this table, okay, of hash function. So for 4, 1, 5, 9, 2, 6. So in the step 1, we find out the hash function for a given stream. In step 2, we try to find out the binary equivalent of it. So now as we know it is 0, we will write it as 0, 0, 0. 4 in binary it is written as 1, 0, 0. 3 will be written as 0, 1, 1. Again 4, which will be written as 1, 0, 0. 1, which is written as 0, 0, 1. 3, that is written as 0, 1, 1. 2, which is written as 0, 1, 0. 4, which is written as 1, 0, 0, and 1, which is written as 0, 0, 1. So we will write down the binary equivalent for the hash of h that we have been calculated. Okay, not for the stream but for the h. So please don't do this mistake. In the step 3, we will find out the trailing zeros. We need to calculate how many are trailing. Trailing 0 means which are ending with zeros. So as you can see, I have 3, so I'll write 3 zeros over here. I have here 2 zeros at the end to 0. 0, 1, 1. I don't have any trailing zeros because after 0 there is a 1. So no trailing 0, that is why 0. So 1, 0, 0 is 2. Here no. Here I don't have any. Here I have 1. Here I have 2. And here I have 0. Right? So like that I have found out the trailing 0. So this is your step 3. We will calculate the trailing 0. In step 4, we will try to find out r of x. So which is the maximum of the trailing 0. Okay, that is the maximum. So if you can see our trailing 0, which we have got from here, the same table we have taken over here, and we are trying to find out what is the maximum of 0, 1, 2 and 3. So as we can see, the maximum of 0, 1, 2 and 3 is 3. So that is why your r of x will be 3. Okay, so in the step 4, we try to find out which is the maximum of our trailing 0, and we represent it as r of x. In step 5, which is the final step, we try to calculate the approximate count of the distinct element. Now for that we use a formula, that is f, which is equal to 2 raised to power of r of x. Now we know the maximum r of x, that r of x we had was 3. So 2 raised to power of 3, which is equal to 8. And so that is why we will see we had 8 distinct elements, and you will also write down which are those distinct elements. If you will see, the distinct elements are 1, 2, 3, 4, 5, 7 and 9. So these are actually 7 distinct elements and not 8. Let me tell you, in FM algorithm or in your Flajolet-Martin algorithm, you always find out approximate distinct elements. You may not get an exact distinct element, and you will mostly, because it is 2 raised to whatever the power is, it will always be an even number. So that is why we say there are approximately 8. See, please understand, that is why it is written calculate approximate count of distinct element. Okay, so that is why it has got 8. If you want to see the question again, we'll just go back and see the question. The question was 3, 1, 4, 1, 5, 9, 2, 6, 5. So from here only actually we can find out 1 is distinct, 2, 3, 4, 5, 6 and 9. So we knew that there are going to be 7 elements, and that is the reason, the approximate value that we considered for this was 8. Okay, so this is how, step by step you will be solving this sum. One more example I want to show you. Again, it has come in the Mumbai University question paper. Let's suppose the data stream is here 1, 3, 2, 1, 2, 3, 4, 3, 1, 2, 3, 1. So this is a very famous question, has been asked many times, and the hash function over here is 6x plus 1 mod 5. Again, the question remains same. Using FM algorithm, estimate the number of distinct elements in the stream. So first you will write down the stream. Before we go to the answer, let us first try to find out what should be the answer. As we can see, this is our stream. So 1, 2, 3 and 4. These are the 4 distinct elements. So your answer should be approximate 4 or 4. Okay, this is how you can cross check. So let's go step by step. So in first step, what you will do is you calculate the h of x function. Okay, so it is 6x plus 1 mod 5. So you will make a tabular format. You will write down which are your streams, and you will also calculate the h of x function for that. So as this particular problem was big, so I had to make more columns over here. So my stream is 1, 3, 2, 1, 2, 3. 4, 3, 1, 2, 3, 1. Right? So this is how we have made this. So you calculate the h of x. So you will get some value. So how will you do that? 6 into 1 plus 1. So 6 into 1 is 6 plus 1 is 7. 7 mod 5 is 2. So for 3 you will say 6 into 3 is 18. 18 plus 1 is 19. 19 mod 5. So that is 4. Okay. Then 2, you will say 6 into 2, that is 12. 12 plus 1, 13. 13 mod 5 is going to be 3. Like that for 4, it is 6 into 4 is 4 plus 1, that is 5. That is 25 mod 5, which is equal to 0. So like that, you will calculate your h of x over here, where you will find out the mod values for the given stream. Now, what is the second step? Second step remains same. You will find the binary equivalent of those. Okay. So as it is 2, you will write down 0, 1, 0. If it is 4, you will write down 1, 0, 0. One catch I want to tell you here, students. Okay. If you see, for 0, we have written here 0, 0, 0. In the previous example also, we have written 0, 0, 0. Okay. I just want you to remember this. We will be doing something about it in the next step. Okay, so here again you will find out the binary equivalent for 1, 3, 2, 1, 2, 3, all the stream. Okay, and you will write down which are the binary equivalent. Okay, this was your step 2 of writing. You remember in step 3, you will try to find out the trailing zeros. Due to a less space, okay, and I wanted to clearly explain, so I have removed this calculated hx. I have only kept stream and binary equivalent in the next step. Okay, when you are doing it in the exam, you can make a table wide, okay, and you can enter the values. So as you know, for the stream it was 0, 1, 0. So the trailing 0 over here is 1. Here the trailing 0 is 2. Here there is no trailing 0. For stream 1 there is 1. Here no. Here 2. For 4, 0. Please understand. In the previous example, okay, also we had 0, 0, 0, and that time we had written trailing 0, 3. Let me tell you, students, in your big data algorithms, you need to sometimes do modifications. As I knew that I wanted 8 distinct elements, that is the reason this 0, 0, 0 has been considered as 3, because I wanted what? My maximum R of x to come as 3. If I would have written 3 over here, again what I will get? I will get R of x. That is, means you are calculating in your next computing. Here if I write 3, my R of x will become 3. If that happens, my unique elements will be 8, which is wrong. That is the reason, students, at this point only, at this point, you will write here the trailing 0 as 0. So please understand, in exam, whenever you have a sum like this, you first manually yourself calculate how many distinct elements should be there, and depending upon that you will manipulate little bit of about your, the only issue you will face is when you have this 0 0 0. In other cases you cannot do anything, that is quite straightforward. Clear? So here you will find out 2 1 2 2 1. Okay, so we have done it. Next, what is our next step? We have to find out the maximum of trailing. So let's see. Oh, so R of x, which is the maximum of count of trailing. So you know maximum is 1 2 0 1. So maximum is 2 over here. Okay, so 2. So R of x will become 2. So हमारा R of x क्या हुआ? 2. So what is the final thing? To calculate the approximate distinct count, what you will say? 2:2, that is 4. And you know which are those elements? It is 1 2 3 4. Okay, so this was all about our FM algorithm. The only catch I want you to understand is such questions can come. Okay, so for that one more thing I just want to show you, that last time when we were discussing, we also discussed about our question papers, right? Most of the question papers you will see this questions have come. Okay, so here only let me show you. If this is the December 16 question paper, yes, here the FM algorithm was asked, and see the same question we have taken, that is 3 1 4 1 5 9 3x plus 1 mod 5. When you get a question like that, students, please first you yourself calculate how many distinct elements have to be there, and approximately, if required, you should modify your 0 trailing one. Okay, this was about your December 16. One more paper I wanted to show you, which talked about different FM algorithm. Let me just check it once. No, it was not there in December 17. December 18, let me check. Yes, December 18. Yes, if you see, the same question was asked. Suppose a data stream consists of 132, 1324. The same question we have solved, students. Okay, with the hash function 6x plus 1 mod 5. So this sum has also been asked. Okay, there is one more type of sum, students, where more than one hash function has been given to you. We will also make a video on that, how to solve a sum where more than one hash function is given. Okay, if you search some question papers, you will get it where more than one hash function was asked like this. Yeah, suppose a stream is given 216159235. Let the hash function all be h of x is ax plus b mod 16. Okay, ax plus b. Okay, it is not 3x 4x 5x, no. And here the value of ABC is being given to you. Okay, and 2x plus a is h of x, that is 2x plus 3 mod 16, b is 4x plus 1 mod 16, c is 5x plus 16. So when you have such question, okay, a stream of data is given to you, more than one hash function is given to you, then there is a different way to solve a question, for which we will make another video in which we will detail explain you how you're supposed to solve that sum. Please understand, in this question paper they have strictly mentioned that you should treat the result as a 4-bit binary integer. So please understand, it has to be 0 0 0 0 like that. Okay, it cannot be 3-bit as how we were taking in our example. We were taking 3-bit because highest what we had was 4, and 4 could be represented as 100, right? So here they are specifically saying that you have to take a 4-bit binary integer. So this particular sum or similar type of sum, we will have one more video where some more information about the FM algorithm has to be given. Most of the time, this 2 or 3 questions, if you refer the question papers, these questions are only being repeated. So you can see that. Okay, thank you so much. I hope you like the video. Please comment, like and subscribe. Thank you.